Okay, problem 3. A very long, solid, positively charged cylinder has a radius r, and is made of a non-conducting material. Here we have r between the charged part, the cylinder, with a thickness dr. Now, and a length L. Now, dq by definition equals rho dv. But what does dv equal so that we can get it in terms of dr? Well, dv simply is 2 pi r L dr. Substituting dv into this part, we get dq equals rho times 2 pi r L dr. Now, the question asks for find the expression for the charge per unit length. So what we're going to get is Q divided by L. So let's integrate. Here we go. Integration will give us Q equals the integral of rho 2 pi r L dr, moving all constants out and substituting this equation, which we have here, rho of r equals rho naught, parentheses 1 minus small r divided by big R, close parentheses. We're going to substitute this into this rho and move all constants outside of the integral. So let me show you what that looks like. Q equals 2 pi L, and then I moved 2 pi L, and here we have the rho. I'm going to substitute rho naught 1 minus r divided by r times r dr. Now remember, find the expression for the charge per unit length. So we're going to divide both sides by L, which would give us Q divided by L. Also, we're going to distribute this R out and move this rho outside of the integral. So it will look like this. Integral, and then distribute the R minus r squared divided by r dr. Now let's not forget limits. Okay. So this is actually quite easy to integrate. So let's just integrate. Equals 2 pi rho naught. So the integral of r is 1/2 r squared, and the integral of r squared is going to be 1/3 r cubed. Okay. Now substituting okay, so as I was saying, for r equals big R, we can substitute and we'll get Q divided by L 2 pi rho naught r squared minus divided by 2 minus r cubed divided by 3r. Now of course you'll see that this r and this will cancel, so that'll give us r squared over 3. Now, this is quite simple. R squared over 2 minus r squared over 3. So what's 1/2 minus 1/3? That's 1/6. And we have the 2 over here, so this becomes and just to make it clear, this is our answer for A. Now, for part B, it says we have to find the magnitude of the electric field outside of the cylinder. Now, for that, that means that small r will be bigger than big R. We have to use Gauss's law in this case. So that the equation is this. Okay? Now, this, the area of the cylinder is, well, let me write over here. This would equal the electric field times 2 pi r L, which is the area of the cylinder. And that equals, now remember we have our Q over here. So Q would equal this, but multiply L over here. So Q would equal pi rho naught big R squared. Remember, we have to bring the L over, L divided by 3 epsilon naught. So this is our equation. Now, this is really nice because many things cancel. This small r is actually like that. So we have L cancels. We have one of the r's cancels. We have pi cancels. And we solve for the electric field. That's what we're asked to do. It says find the magnitude of the electric field. So the electric field is rho naught r divided by, now the 2 goes there, so it's going to be 6 epsilon naught. Oh, I'm so sorry. There's a small mistake. This is not a big R, this is small r, sorry. Small r. This does not cancel. This is still squared. So this is going to be squared, sorry about that, r. And this, yes, this is our answer for B. Okay, so for C, we're asked to calculate the magnitude of the electric field inside the cylinder. Well, that means we have to go back to this equation, and we're going to take, again, Gauss's law. Gauss's law one more time, which will give us, hold on, and that's going to equal Q over epsilon naught. Now the Q comes from here. So this becomes again E. That's the left side of the equation. And that's going to equal Q. Remember, moving the L back, this will give us 2 pi rho divided by epsilon naught times r squared over 2 minus r cubed over 3L. Now, here we can cancel many things actually. We have the L and we have 2 pi cancels and one of the r's cancels. This becomes 2. So let me rewrite it so that it looks neater. We have E equals rho divided by epsilon naught, rho naught divided by epsilon naught, times r over 2 minus r squared over 3. Oh, I forgot to mention, don't forget the r, so there's the r. Okay. Okay, so that is the answer for C. So for part D, we're allowed calculators, right? So the easiest way to sketch the magnitude of the electric field as a function of R is to use your calculator, your graphing calculator. What you should get is something that looks like this. E, R, looks like that, to a point. Then it declines. And this is the R-axis. This is the e-axis. And that is what your graph should look like using your graphing calculator. Okay, so the potential E, the part E, the potential difference between the axis and the outer edge of the cylinder. This is the last thing we need to calculate. So for E, what we need to do is find the potential difference. So it's going to be delta V, and that will be the integral of E with respect to R. Now E we have from part C, so we just plug in. It's going to be the integral of from 0 to R of rho naught divided by epsilon naught R divided by 2 minus R squared divided by 3 big R. Oh, yes, of course, dr. So removing or moving actually the constants over outside of the integral sign, we should get this. And this becomes actually very easy equation to integrate. What we get is rho naught divided by epsilon naught. Then the integral of R divided by 2 becomes R squared divided by 4. The integral of R squared divided by big R will become R cubed. Oh, sorry, the 3R, I forgot to bring over the 3R. 3 big R, capital R. So it'll be 9. From 0 to R, don't forget our limits, 0 to R. Now, plugging in, we will get equals rho naught divided by epsilon naught divided by R, big R squared divided by 4 minus R cubed, large R cubed, divided by 9R. Now we can start canceling out a little bit. We have 1R here, 1R here that we cancel. And if you notice, we have R squared, so we can actually bring that outside. It'll be R squared, and we'll have 1 over 4 minus 1 over 9. So finding, actually just simply subtracting, this becomes, the final answer becomes 5 over 36. It's just simple fraction subtraction. Rho naught R squared divided by epsilon naught. And that is our potential difference.